Hi YouTube. So I got a request on how I did something in Inkscape, piece of art I made after we finished a advanced design course in engineering. So basically I was really fascinated with the conjugate gradient method, and this is the formula for it over here, which you might recognize. And I was just playing around drawing the conjugate gradient method in Inkscape, um, and I noticed that, well, if the light comes from exactly this side, I mean, I know it's a two-dimensional drawing, right? But if the light comes exactly from this side, if these triangles stood upright, then the shadow of the um, conjugate gradient method lines up exactly with the starting point of where your search begins. Um, and then basically I just added the formula and the shadow and stuff like that. So I'll sort of recreate this and then show how I did the effects. Okay, so let's start with some shapes. So I won't create the conjugate gradient shape. I'll do some other random one. So let's make a simple geez, I don't know. Okay, so what I decided we should do is a little bouncing ball thing with some cool equation that sort of represents the physics behind the ball bouncing. I did this for 3 minutes before, realized I didn't press record, and then had to start over again. It doesn't matter, we can make it more smooth in that case. Let's start with a basic ball bouncing path. So I'm going to take the line tool, and it's sort of a hop, and then a apex, and another hop, apex, another hop, apex. So it's going to continue like this until the ball just rolls along. Let's make this one slightly faster, like this. And then we're going to just make sure these are on the, I don't know, this equalizing thing. Make them look more parabolic, and make them each have equal, make sure these handles are equally stretched on both sides. Then the ball obviously has to hit the floor at the same point each time. So what you're going to do is just draw a line from there to where the ball rolls, and then make sure that each one of these points are on that line. Otherwise it looks like the ball is like hopping left to right, or just stopping mid-air or below the floor. And then ideally, obviously, if we're going to assume there's friction, then each one of these hops should be a little bit closer to each other as it loses energy. And but I'm going to eye it for now. I think I should actually move these a little bit closer. It looks like it's like on a floor of ice or something, so it's not losing energy. Then the formula I think we should use something like a Hamiltonian mechanics equation to represent the ball bouncing, because it's got some cute symbols and stuff in it, and it looks all scientific and advanced. I mean, it is, but it's just another way of writing a parabola, I guess, in momentum terms. So okay, this is fine for now. Let me just add a ball, and we can delete that line for now. Let's go with like a turquoisey blue theme. So I have to delete the stroke. I don't want the stroke, but I want it to be filled. So I'm going to make it a high saturated blue ball like this. Let me make it a little bit bigger. And then let's do the background. So this background was sort of I added the shadow because the background, I don't know what they call it, the infill gradient, the gradient infill for Inkscape takes a conic section ellipse kind of style, and the ellipse or the conic section is exactly what the conjugate gradient here is following to the maxima of light, I guess. You know, that's all big words, but it's just going to the highest point of light. And it's just nice that Inkscape has a conic sectiony gradient method that just fit in with the theme. So what we're going to do is going to edit the center to be slightly lighter than the outside. So let's click on the outside, make it full saturation, and then nice and dark. More turquoisey. So let's go this way. Somewhere there. This one's not very turquoisey. Let's go a little bit slightly left. Okay, then we move the background back. Now obviously the line has slightly disappeared, so let's make that white. So I'm just imagining like we're looking at it slightly from the top. So obviously the line's going to disappear somewhere there behind the ball, not there. It looks weird, so that's where it lies. These hops are not that great. I think I should structure them a bit more. So what I'm going to do is just do a few construction lines. I'm going to go straight up. I'm going to assume this one is very nice, and then I'm going to just, with the same angle, make sure I have the thing at the same angle, place these where I think they should have been to get the right size of hops out of this thing. Okay, so let's move this one slightly closer and give it more of a sharp edge. And then this obviously has to be in the middle. Sharpish edge. And then this is the last little hop, and then we can lift this one up slightly to, whoops, not like that, act as if that's its final hop. Okay, so using these construction lines, I think it was a little bit better. Let's just delete them for now. I still don't like the bottom hop here, and also this line is sharp over here, so what I'm going to do is click on this button, and then that should make them all flat where it hit. I'll work on the hops a bit later, so I'll just continue with what I was going to try and do. So let's find a Hamiltonian equation that represents the physics of this ball.
12 seconds later.
Okay, so in the search, I read through like 2 or 3 papers trying to find a. I mean, this is a really simple example. I usually use Hamiltonian equations for something really complex in advanced dynamics systems. But I found a paper which, oh, it's not really a paper, it's just a website that showed a disproof of Zeno's paradox. I don't know if you guys know what Zeno's paradox is. It's basically the idea that, to get to a point, you had to travel half the distance first, and then half that distance, and then you keep subdividing the distances that you traveled. So it means, in actual fact, you had to travel an infinite amount of infinitesimal distances. So how can you ever get anywhere? But anybody that understands integrals will know that's not true. And what this guy found is actually that a bouncing ball, the trajectory height of the ball follows a parabola like this. So that gives us an even better approximation for what we're trying to draw here, which I didn't expect. So we're going to make these bounces follow this this parabolic curve, and then I'm going to use that formula that he had there. I'm just going to sort this out so it looks like it's actually upright, so we can get like a much better, whoops, make that line up with the floor. Stretch this out slightly. Okay, so this one has to go down. Let's see if that looks better. Yeah, except for these. It'll obviously start bouncing slower, so I'm just going to bring these in. Actually, the first one I drew before I had to redo this because I didn't press record was just by chance looked really good. I might be, it just, in my head, some of this doesn't look like it. Maybe you guys are going to be like, dude, it looks fine, chill. That's not right. Something that's not right. I'll cut this out of the video if this becomes too pedantic, really. but this has to look right. It can't be like this. It's too round. I think it's too round. Like no, but it's not going very fast. So you know what? This should have been done with maths. I didn't do it with math, and this is the result. Okay, so let me just find that equation quickly. Copy it over here. So copy image, and then we're going to redraw this in SVG, obviously, because we want that. So it looks like they used Microsoft's Word equation generator here. We'll do this in parts. So h of t. Oops. Let me just look for a font that matches this. I think we'll try. There's something called Mathematica. I mean, the other option we have is just to make it look like handwritten text. I guess we can do that. I didn't intend for this video to be very long or take much time, so I'll just stick with this for now. So the formula goes like this, and then we'll split it up in parts where we have to split it up. So is G. Okay, we're gonna have to separate the 2 out there, so we'll make it 2. We'll separate the G on 2, we'll separate that out. And the equal sign has to be done manually because apparently this so we're gonna have to do the brackets ourselves as well. Just copy and paste this and make it go 1 minus. Oh, we're gonna have to do the square root as well, so we'll put a space and we'll put an R, so we have to write that in ourselves. And then we'll just copy and paste this one for the bottom one and go, whoops, he's telling me it doesn't have a plus. No, but it does have a minus, so we'll use the minus and we'll turn it into a path, and we'll copy and paste the path. We need the square root as well, which we're going to use twice. Then we need to just copy and paste the 2 for the square. We have to make the brackets. So let's convert all of these to path. Text, no path, stroke to path. Let's see if that did it. Yeah, there we go. Oh, that's a dirty path. Maybe we can simplify it. We can do this and go path, simplify. It doesn't look much worse, I guess. Let's see if we undo it, redo it. Yeah, see, but it's going to be a little bit easier on the computer, I think, because this looks bad. Let's highlight all of these. See, path, simplify. There we go. Oh, that's interesting. It looks like Inkscape takes some. So when we did it with a 2, there was a lot more left over. So I think it has a limit to how many points it adds, because all of these together, they've only each got like 10 points now. But previously it left quite a few points in this one when we did it like this one individually. I mean, it's not too bad. It's lost some of its character, but in terms of just keeping it simple, okay, let's do this for now. I can always change it later. So now that we have this, I'm going to go ungroup. Okay, then we need to do that square root thing, right? So how will this look when it's done by hand? I think it'll just be like a rush job of going up and then ending at an angle because of the velocity of your hand, something like that. Let's add some more character to it. So where will the pen go thicker? Let's say on the horizontal strokes. It's now an ugly G. Okay, whatever. So what do we have here? The height in terms of time is equal to G over 2 times 1 minus r squared over 1 plus r squared. Rotate this around. Whoops, don't move that. Flip it. And let's squeeze it so it looks different. Minus, minus, that's the only plus. G times 1 minus square root of r. V0, d minus. Okay, so I think this formula looks fine. I'm going to move this out of the way. Then I'm going to group this and I'm going to bring it in here. So let's make it sit underneath the big hop. So I'm going to take this and the ball. Ah, come on. There we go. I'm going to take this and the ball. I'm going to group those. And it's a bit big, you know. So to make it look like it's in line with this hopping thing, you have to play with the shear. So this is how it looks normally, and then to get the perspective effect on it, click again, and then you sort of have to shear it, right? So if you can see, shearing the top makes it lean up and down, and shearing the sides make it lean. It's very counterintuitive. Make it lean left to right. So I'm going to shear it like this, and then see if I can line up the text to look like it's in line with this. I'm also going to change the fill to white, and then I need to, you know what we should do? Maybe we should make it hop on the equation and then off. So we can move this like that. Like I said, this is a rush job. Like I'm just trying to show the shadow effects and stuff on here. So if we now copy and paste this formula, and now we want to make a shadow out of it. So first we'll just make it black, and then what I'm going to do is I'm going to shear it. Let's see which is the right shear to use. This one, and then I'll think as well we have to rotate it. Now I can see it's still nope. Again, I'm shearing it back to how it was, so I have to do this. Man, I think I used to be a lot better with this. Oh, and also make it lie flat. Okay, so you have to, I mean, there's some manual transforms you have to do with your eyes, basically. You know, there are tools on Inkscape that can make it go, what do you call it, isometric, but this isn't necessarily isometric view of this thing. So man, this is taking a little bit longer than I thought. Okay, let's move it down and back. So I'm going to use the arrow keys. Let's make it hover slightly in the air like this, you know. And we'll make the line a shadow as well, and we'll give the ball a shadow at the same time. So we're going to do the same with this. We're going to squish it down, and then we're going to shear it, and we make these. So with this it's easier because here we can shear it till the points line up with the bounces, you know. Okay, that took a while, but I think that's basically what I'm... Oh, no, I don't want... No full, no full. This is all a stroke still, so let's make the stroke black. Then this ball part though, that can get a full. So that's filled. And then that has to go to the back. No, it's still in a group. Ungroup it. To the back with you. And then this has to sit in front of everything else, so bring that forward. Okay, now obviously what makes the shadow look a lot better is when it fades to the back. So now we've got them in the right place. What we now do, I'm going to do it first with the bounce part, is I'm going to apply a gradient to the stroke, and then obviously just select the gradient to be very, very strong, close to the ground where it's located, and then weaker further back. Again, this takes some playing around with, especially because I can't make the gradient strong at only these points. I sort of have to find a line of best fit for this shadow. I'm going to also fade it slightly. Okay, and then what I'm going to do is I'm going to increase the thickness. We try to get the shadows to start off strong and then end all smudged at the end there. So it's easier. Like if we take this to GIMP, then we can very easily smooth that out. And I mean, that's how you would do it if you wanted to look really nice. And but if you want to do pure Inkscape wise, I might be missing something, but I'm not sure how to individually put gradients on nodes, because then I would select, whoops, I would select this node and just make its gradient a lot less. Let me just get this down. So see if I can fade this out so it looks better. So that's not too bad, I guess. Same with this shadow. This shadow should also be blurred a little bit. Okay, well, since it's not going to fade away, what we might have to do is just blur it a little bit and then bring its opacity down like that. And we can blur it in a program like GIMP, so on. This line, we can make it end about there. Oops. And this one that fades into the distance. So I'm just cleaning up some stuff here that doesn't look right to me. And a lot of things we're going to have to clean up in GIMP if we want it to look super great. But that's basically how that effect is done. I think this shadow needs to be moved down a bit, like that. Okay, cool.